Okay, Assalamualaikum and hi. First thing first, thank you to Dr. Roshaliza binti Muhammad Ramli to teach us in this whole semester. Okay, my name is Hafiq Rukaini bin Muhammad Ruzaini, TB18050.
My name is Muhammad Nazirul Muhaimin bin Zainuddin, TB18042.
My name is Dira Nadia binti Padil, TB18053.
Okay, today we are gonna present our project that called Amplitude Modulation Transmitter. Okay, for our information signal is 2.5 kHz and our output signal is 2500 kHz.
First of all, the communication system design course show how the amplitude modulation mix the modulation signal and carrier signal and produce the modulated signal. The results are shown in each output waveform with proper calculation of the mixing between the information signal with a carrier signal. Amplitude modulation means an impressing data on an alternating current carrier waveform and commonly for transmitting the information via a carrier signal. It is used for radio transmission for broadcasting and two-way radio communication application. Double sideband full carrier is the amplitude modulator that change according to the voltage input of modulation signal and carrier signal. It consists of the carrier wave and two sidebands during the process of amplitude modulation, while the sideband is a band of frequencies that contain power, which are the lower and higher frequencies of the carrier frequency. Besides, the output waveform of the double sideband full carrier is in envelope shape. We can see at the slide the output waveform shape of the SBFC and how the amplitude change. The advantage of AM signals are firstly the simple characteristic implementation in the communication system, and secondly the cost is cheaper than others due to no additional special component required. Next, for the limitation of AM signals, firstly, it is not efficient in terms of the power consumption, and secondly, AM receiver will receive more noise compared to other types of modulation. So, what is the objective of our project? Our objective is to explain the concept practical for designing the output signal in telecommunication applications, reinforced by proper calculation of the mixing between an information signal with a carrier signal. For the function of each system components block, firstly is the power supply. Power supply function to utilize to provide electric power, current and voltage to the transmitter for circuit operation. Next is oscillator. Oscillator is a device that is used to produce a sine wave oscillation. The AM modulator can be given a stable carrier frequency to the modulator by attaching the oscillator to it. Then the modulator. It is a device that puts the information signal onto the carrier signal to create a modulated signal. Power amplifier is an electronic device used to increase the immensity of voltage, current or power of an input signal. Lastly is the information signal. It is a frequency that contains data or a message that is broadcast through the radio, television, smartphone or other communication system.
Okay, for the design, that have 3 steps. First thing is we design our oscillator circuit. Second step is we design AM modulator circuit, and lastly, the third step is to design the power amplifier circuit. Okay, the reason of the design step is in our project, the oscillator is a device that generates a reliable carrier signal for the AM modulator. The Hartley oscillator was chosen for the project because its design is simple for everyone, and the formula for calculating the frequency produced by Hartley oscillator is likewise simple. Okay, this is our calculation formula. Okay, the purpose of utilizing an AM modulator is to achieve amplitude modulation. The final reason for employing the power amplifier circuit is to send power to the load, which is the product of the voltage and current applied to the load. with the output signal power being greater than the output signal power as we learned earlier. Okay, this is our design circuit of AM transmitter. We have oscillator, AM modulator and power amplifier. We combine it all until into one. So our carrier signal is the oscillator, and our information signal is our function generator.
For implementation with commercial component, reason behind choosing specific component is we use VCC with quantity 2 for the VCC to supply power to the circuit. Then DC power we use 1 DC power to supply the circuit also. Then for the resistor we use 9 resistor to control the flow of current. Then for the capacitor we use 8 capacitor for function store electrical energy. Then for the transistor we use one transistor BC547 BP. Then for the amplifier signal, then transistor also we use BC107 BP for AM transmitter signal. Then for transistor we also use transistor 2SC945 for oscillator signal. Then information signal input we use 1 to plug in the information frequency. Then lastly the function generator we use to produce various pattern of voltage. For discussion and conclusion, outcome of the project, we were unable to obtain the output frequency after multiple tests. However, we were able to display the envelope shaped waveform. Then for improvement, amplifier in class A, class B or class AB are some of the suggestions for improvement. This amplifier may be able to produce a more precise output signal. Therefore, our conclusion, finally, we have received a great deal of knowledge about the AM transmitter. After that, we also able to familiarize ourselves with how to construct an oscillator configuration circuit using the oscillator frequency formula, as well as how to construct a modulator circuit. Then we also using the project output, we may understand the function of a power amplifier. This as we can see is for row of each member. Then this for our reference. That's all for us. Thank you.
Thank you.
Thank you.
Assalamualaikum. My name is Mastura binti Hassan, TB18045. My groupmate Nisan, Khalid and I will explain about the AM transmitter system determination. In this system, we use 2.5 kHz of information frequency and 4000 kHz of transmission frequency. I will explain about the block diagram of this system. In this block diagram, we use Colpitts oscillator, information signal, AM modulator, modulated signal, power amplifier and antenna. We use a Colpitts oscillator because Colpitts oscillator is a LC type oscillator which is designed for generate high frequency sinusoidal oscillation. Okay, signal from Colpitts oscillator will go to AM modulator. In AM modulator, we'll use information frequency from signal generator and signal carrier from Colpitts oscillator. From AM modulator, it will modulate the signal and get the modulated signal. The modulated signal will transmit to power amplifier. The power amplifier will boost up the signal, will boost up the amplitude and send it to the antenna. And antenna will transmit the transmission frequency to the receiver.
Hello, my name is Nixon Anthony, TB18162. My teammate just now, Mastura, explained about the flow of the circuit. So now I'm going to explain the circuit in this simulation. Okay, we see at the Colpitts at the oscillator we use the Colpitts oscillator. We know that the signal classification for carrier and message frequency is periodic signal, that is a sinusoidal signal. For the carrier signal, we use tune oscillator, this Colpitts oscillator. In this Colpitts oscillator, this parallel tune inductor and capacitor tank circuit determines our carrier signal. We adjust the value until we get the desired frequency needed. Then this Colpitts oscillator is then connected to the AM modulator circuit. For the message signal, we use the function generator 1. The function generator 1 we use to generate the 2.5 kHz frequency and also 12.5 volt voltage peak to peak, because the oscillator that I mentioned just now, the Colpitts oscillator, use 12 voltage supply to supply the Colpitts oscillator. This message frequency also connected to the AM modulator. This modulator then perform modulation process where the information is put onto the high frequency carrier for transmission. This information signal modulates the carrier by changing either its amplitude, frequency, or phase. The modulated signal is then sent to the power amplifier before transmitting the signal through the antenna. Okay, that's the brief explanation for this circuit. For the simulation result, I leave to Falik for the explanation and also conclude all of this simulation. Thank you.
Assalamualaikum, my name is Falik Zainuddin, TB18154, and next I'm going to continue our presentation about the result and conclusion. So as for the result, in overall we can say that we have completely succeed to achieve our desired value, which are 2.5 kHz for information signal and 4000 kHz for transmission frequency. So with this presence of modulated signal, which is 4000 kHz, we have already calculated our modulation index, and the answer we got is our waveform is in under modulation, which is the M is lower than 1. So from the result also, we can see the changes happen for the waveform when mixing carrier frequency and information frequency. So refer to the output result from the oscilloscope. This one, it can be seen that the envelope of the signal frequency of the signal follows the curve of the modulating signal. This is because in amplitude modulation, the amplitude of the carrier wave changes according to the message signal. And by looking at the transmission frequency or modulated frequency, it is changing over the time. So you can see here on the red one, this is our transmission frequency, 4000 kHz. It is not a smooth waveform, but it still have a noise, because in communication transmission we have to consider a presence of noise even we have designed a perfect circuit. So next for the conclusion, as a conclusion, amplitude modulation technique is widely used in AM transmitter. In this process, the amplitude of carrier is varied in proportion with the amplitude of the modulating signal, keeping its frequency and also its phase constant. So this transmission is widely used in application like for example radio or TV broadcasting. So that's all from us. Thank you.
Afternoon, doctor and my friends. We are from Group 3. Project title is AM Transmitter. I'm Chen King. Now I want to start my presentation introduction. Okay. The AM modulation is the process changing the amplitude of a relative high frequency carrier signal in proportional with instantaneous value of the modulation signal. The modulation signal means the modulate the carrier signal. The information contained in the modulating signal can be efficiently radiated by an antenna through free space by radio frequency RF. Next slide. Okay, this one is the AM generation. You can see the AM double sideband full carrier, the envelope. Okay, next slide. Okay, this one is a frequency spectrum of an AM double sideband full carrier wave. Okay, next one. Okay, the modulation index range 0 M1. The 100% modulation is M equal to 1, EM equals to EC. And then the trapezium diagram is like this. The M less than 1, EM less than EC. M more than 1, EM more than EC. If no modulation means M equals to 0, only the carrier wave being transmitted. Okay, next slide. This one is our project block diagram. The oscillator, filter, AM modulation, information signal, output modulation signal. The oscillator will bring out the carrier signal to the filter, and then the information signal will go to AM modulator juga, and then go out to the output modulated signal. Okay, next.
Okay, for my name is Nik Muhammad Arif. For the oscillator, we use a Colpit oscillator. That is because a Colpit oscillator is a tuned oscillator and a self-sustained oscillator. Okay, next. This is the circuit for our Colpit oscillator. Okay, next is the AM modulator. AM modulator is a device that used to produce a modulated signal by putting the information signal onto the carrier signal. Okay, for the circuit, this is the circuit for our AM modulator. Next is the power amplifier. The power amplifier is to enhance the voltage of the signal to make it a bigger wave. So for the circuit, this is the circuit for our power amplifier. Next is the AM transmitter circuit. This is all the circuit that I have mentioned above that have been connected to one another. So for the component, this is the component that we use in our circuit. So next is the 2N3904. The 2N3904 has a gain value of 300. Okay, next is the LM741. The operational amplifier is a DC coupled high gain electronic voltage amplifier. Okay, that's all for me.
Okay, my name is Muhammad Akil. Now I would like to explain about the outcome of the project. Okay, this is the circuit that we designed. Okay, all the circuit that we combine and then we set the information frequency as a 5 kilohertz in here. Okay, and this is the waveform. The yellow one is for formation carrier frequency, and the blue one is the modulated signal. The modulated signal frequency is 4.87 megahertz, and this is approaching to 5 megahertz. Okay, the purple one is the information signal that we set on the function generator 5 kilohertz. Okay, for improvement, as we can see in this waveform, our modulator signal is not perfect. It is not exactly the envelope shape. It may be caused by many issues. To improve the circuit, we need to try use another oscillator, which is Hartley oscillator or Wimbrage oscillator, and we need to try an error to build the better circuit and get a perfect modulated signal. Okay, back into the slide. Okay, this one is a Okay, this one is the group contribution for the research on this project problem and main idea done by all of us. The design and construct the diagram and circuit also done by us, and then the implementation with commercial component selection done by Nick and myself, and finally finalize the report done by Chiking and Nick. Okay, for the conclusion, from this project we know how our AM transmitter works, and during this building the circuit, we have learned how to build an oscillator, power amplifier, and AM modulator circuit, and combine them to become a complete circuit. Okay, that's all from us. Thank you.